So what we have here in front of us is basically a photon that's traveling in the positive x direction, and it has its original momentum, wavelength, lambda O. That's before interacting with the electron. But then after hitting the electron is going to go this way, and the photon is going to go in this other way, and it's going to have now a different wavelength than before. Now, the angle of the divergence of the photon from its original path is called theta, but the angle of divergence of the electron from the origin point is this symbol, which is psi. Okay. In an experiment, a photon of wavelength lambda O moves in the positive x direction toward an electron that's initially at rest at the origin of the xy plane. The photon and the electron interact, that means they collide, and the resulting photon of wavelength lambda f and the electron move in the directions that are at angles theta below and the other symbol above the x-axis. Okay? So, respectively, as shown in figure 2, the experiment is conducted as described. Okay. Well, in figure 3, sketch the expected relationship between lambda f and cosine theta for the experiment. Okay, it's time to bring up our reference sheet. So in our reference sheet, we're looking at this equation here to work with, where delta lambda is equal to h over me, mass of electron c, multiplied by 1 minus cosine of theta. Let's take it back to the question. So going here, guys, let me start with the following. So what is the delta lambda? It means the change of the lambda, which means lambda final minus lambda initial. So essentially lambda final is equal to change in lambda plus lambda original. Okay. Now let's just start with cosine being a 0. So delta lambda is equal h over mec multiplied by 1 minus cosine of theta. And cosine of theta here at the origin is going to be 0. And so 1 minus 0 is a 1, probably, right? And so basically the lambda f is going to be equal to the lambda O plus h over mec. That means in the beginning the lambda f has to be larger than lambda O. Okay? Now, how about at 0.5? So now when the cosine is 0.5, let's do the math again. We're going to have 1 minus 0.5. So you're going to have lambda O plus this times half. So did our lambda f now drop or not?
It did.
It did, right? Because now instead of getting the whole h over mec, we will just get half of it. So now it's going to drop. Okay, and now finally when the cosine is equal to 1, so we're going to have here 1 minus cosine. Instead of cosine, we're going to put a 1, and so we're going to have the whole thing is equal to 0, correct? That means ultimately lambda f is equal to lambda original. So that means when cosine is 1, they will be equal to each other. Continue the line. So it's going to be the line decreasing over time from a point above lambda O to lambda O in the end. Okay? Any questions?
Mr. Are you recording?
Okay. Double I. In one trial, theta is equal to theta 1, and the kinetic energy of the electron after the interaction is equal to K1. Derive an expression for K1. Okay, let's do that. So, essentially, the energy of the photon before is equal to the energy of the photon after plus the K1, which is the kinetic energy of the electron. Correct? So we're going to say that K1 is equal to E photon before minus E of photon after. Now, who knows the equation for the energy of a photon? Who knows what that is? Is it HF? Yeah. Do you guys know that?
Why did you say it like it was something else?
I mean, looking at the faces here, everyone's like...
I'm trying to understand.
Okay. So HF before, which is O, minus HF after, which is the final. Yeah? Okay. Now, do we know that C is equal to lambda F? And so F is equal to C over lambda? That's common knowledge for physics students. So we're going to have H C over lambda O minus H C over lambda final. Okay, now let's look at what they want. Express your answer in terms of lambda O, which I did, in terms of theta 1, which I did not.
So
Yet.
you don't get points for it.
Not yet. And physical constants, which I did, because C and H are physical constants. So I have to further modify my equation to show that theta 1. How would I do that? Well, as you guys know, delta lambda is equal lambda F minus lambda O. And so lambda F is equal to delta lambda plus lambda O. So I can go ahead and I'm going to change the lambda F into delta lambda plus lambda O. So what's delta lambda? This guy here. Yeah. So it's going to be H over MEC 1 minus cosine theta plus lambda O. So instead of the HF here in the end, I'll replace it with this whole thing. H over MEC 1 minus cosine theta plus lambda O. Theta 1. Okay, because they said theta is equal theta 1. Yeah. So what do you guys think about that?
I would have not reached that conclusion in the exam.
Would you now?
Well, yeah.
Yeah.
Good. Not horribly bad. Okay, so now we finished part A, I, and also double I. Okay, so should I erase that or should I keep it?
No, keep it.
Okay, should I erase? I should erase something else though, because do you guys want to like take a picture or take
No,
notes or
Yeah, just erase it.
just erase all that?
Because it makes sense. You do look at the other steps.
Now, part B says justify why the condition of the angle, which is this one, the specific angle of the photon, has to be 90 or less. Okay, so first of all, let's talk about the photon. The photon before versus the photon after. Which one has more energy? The photon before the collision versus the photon after the collision.
After.
Has more or less energy. A car collides with another car. The first car that collided will lose some speed. It will lose some energy, correct? So we're going to say that the photon before collision, okay, had more energy and frequency than the photon after collision. Yes? Okay. And the lambda F is more than the lambda O. So energy is conserved. So the energy of the photon before is equal energy of the photon after plus the K of the electron. Okay? And lambda is equal to h over p. You guys should know this equation. Lambda is the de Broglie wavelength and p is the momentum. Okay? So since lambda f is more than lambda o, how would I know? How would I know that lambda f is more than lambda o? Because when the energy decreases, the wavelength increases. Because energy final is less than energy original of the photon. So with more lambda after collision, there is less momentum. Momentum after collision. Now, what was the original direction of the photon? It was in the plus x direction, correct? So here we are still within the plus x direction. We still are. We're just at an angle, okay? And since the photon, before was moving in the plus x direction and must continue this direction after collision. It was plus x and it's still going to be plus x, but simply with an angle. Okay, and that's about it.